Welcome to the first of 3 videos that talk about graphing quadratic functions. In this video, we're going to focus on vertex form. To know how to graph vertex form, it's important to know what the parent function of quadratics are. So we're looking at it right now. This is the equation y equals x squared. So notice that when we have the 2 in the exponent there, we have a quadratic equation. The shape of this graph is a parabola. It has a vertex at the point 0, 0, and that's the point where we start to see symmetry. So its axis of symmetry, think of a line going right down the middle at x equals 0, would be where we could fold up the parabola and everything matches up nicely. So this is the most basic quadratic function or parabola that we could deal with. The reason that we want to know this is because when we look at vertex form, we're looking at some version of this graph, except a shifted version. So vertex form has a few pieces to it. Notice that I've colored the A, the H, and the K. So I'm going to first actually talk about the H and the K. That's where the shifting comes from. So I want you to think of that shifting that vertex and all the other points. The vertex is the easiest one to think of because it's at 0, 0. All right, so the H, if that's negative, the way it appears right now in the equation, we would be shifting that graph H units to the right. But if that said x plus H inside the parentheses, in other words, it's positive, we'd be shifting the graph H units to the left. As for the K, if K is positive, as it is in this equation, we would shift the graph K units up. And if K is negative, we would shift the graph K units down. All in all, what that means for us is that the vertex of this equation would be at HK. So in this general form, we will typically see a minus sign here and a plus sign here. And if we see opposite signs, we know to move in the other direction. Now for the A value. That A value is either going to be positive or negative. If it's positive, we're going to have a parabola that opens up, and if it's negative, the parabola is going to open down. Now, you have some experience with graphing lines, and when graphing lines, you typically think of needing a slope to figure out the points. A is not the slope of a parabola, okay, so we're not going to call it the slope. In fact, in the rest of the videos, I'm just going to keep referring to it as the A value. Although it is a rate of change, okay, it's not going to be used the same way that we would use the slope of a line, because we're not going to be getting a line out of this equation. We should be getting a parabola. So notice that I've written something down here which might seem a little confusing, and it's going to become less confusing once you see me do an example. But let me try to explain it. You can use this A value, but you can't use it many times. Okay, and here's what I mean by that. You can do it a single time if you start from the vertex and you use this A value to go that much up if it's positive or that much down if it's negative, and over 1 unit from the vertex. So if this A value is a fraction, I'm not allowed to separate the top and the bottom to mean up and over. Okay, and that's where it's different from a slope. And again, that's a little confusing right now, but you're going to see why that makes sense when we do an example. Okay, so here are the steps to graphing something in vertex form. The first thing, you want to identify that vertex and plot it. So let's just say we have a random vertex here, right? And that's because I can see what the vertex is right away. Next, you're going to figure out at least 2 other points on that graph. So one way would be to use the A value, as I was talking about just now. You could also plug in values close to that vertex. So think of it as maybe going 1 to the left or 1 to the right, or maybe 2 or 3 over, but sticking in this ballpark and simply plugging in that number to try to come up with points. We could continue doing that as many times as we want, but we want to have at least 3 points on this parabola so we can start to see that parabolic shape. And then we can draw in that graph. Let's give this a try. So in our first example, notice we have our A value right here, which is -2. Our H is 4. Notice it says -4, right? That's going to be a moving right 4. And our K is 1. So I'm going to work with the vertex first. I know that the vertex starts at 0, 0. This is telling me that it moves right 4, up 1. So look where that vertex is. That's going to be at 4, 1. So the first step is done. We have plotted the vertex. The next step is to get some other points. I'm going to use this A value. So this A value tells me, because it's negative, that I can move down 2 spots and over 1. So I start at my vertex. I can move down 2 over 1. Now I can do that in both directions because the parabola does have symmetry, right? This is a axis of symmetry right here. But I cannot continue. I can't keep doing down 2 over 1. That would be wrong. That would be a line right here or a V shape, right? So I can't do that again. If I do want to find some more points, maybe I should plug in 2. That would be a good number, or even 6. Let's go with 6. So I'm plugging in 6 for the x value. And I'm going to simplify that to see what the y value is. Just following PEMDAS here. I did my parentheses. Next step was to do the exponent. Now I'm on to multiplication. And lastly, addition. So this was the value that we plugged in for x. That's the x value of our point. This is the value we got out for y. And now we have a complete point at 6, -7. And we have another point right over here because of that symmetry, right? Look at that. They're both 2 away from the axis. I'm going to draw that in now. And we have our first example all done. Let's do one more together. So notice for this example, I picked a fraction for that A value to show you what I was talking about before. But before we do that, I do want to go back to the vertex here. So we're looking at H and K. This time we have a +2. So that meant move left. So if I am at 0 and I move left 2, notice that I'm at -2, right? So it's like we're taking the opposite of that number. The -3 for the K meant to move down 3. We're not taking the opposite of that number though, right? So it's just this number here in the parentheses. So we have our vertex. Let's plot that, -2, -3. And now let's see if we can use this A value. Now it is a fraction, and I said we couldn't split this up the way that we do for lines. We are allowed to go up, because it's positive, we're allowed to go up 1/3 of a box, because the boxes are worth 1, and over 1. So we're allowed to start at this vertex, go up 1/3 of a box. See why that's really hard to do? Like you can't really be exact with that, right? But we're approximating, that's fine. Up 1/3 and over 1. So there must be a point right here. Whoops, and I'm going to do that in the other direction as well. That's not the best point to put on a graph, right? Again, because it's not exact. Let's get some more points on there. I will give you this suggestion. Notice that the 3 is in the denominator here. My suggestion is that you go 3 away from this vertex. So see how it's at -2? Let's count 3. 1, 2, 3. 1. So my suggestion is to plug in 1. And the reason I say that is because it's going to help you get some nicer numbers here to deal with. Look what happens. Inside the parentheses, we get a 3, and when we square 3, we get 9. See how I have to multiply this 1/3 with a number? Because I went over 3, I was able to get this multiple of 3 here, so that 1/3 of 9 is a whole number. All right, turns out I got 0. So I know that there's a point at 1. We plugged in 1, and we got 0. Let's plot that. And here's the axis of symmetry. So this point was 3 away from the axis of symmetry, so there must be another point right over here. And we could keep going if we want. I think this is good enough for now. Just connect these. We have finished our second parabola. So there are 2 examples of vertex form. Remember, this is the first of 3 videos in a series of graphing. So I hope you can watch the next one about factored form.